So once again, it's a privilege to be in front of you, and I'll dive straight into the presentation. I've already been introduced, so not much to really say here, other than the fact, I guess, that I've been working in this field for I can't believe almost 3 decades, but it's a great field to work in, and so I've enjoyed, every year that I've been working in the data space. A lot of the work I personally do, especially recently, has been in the government sector, probably because they have a hell of a lot of data, and they need to manage it, figure out how to use it, leverage it, make policy decisions, and do all that sort of thing that you need to do with data. So a lot of government work in recent years, and also, well, you can see there my interest, data. This is not, of course, in order of importance, family, footy, and I do a bit of running, although I should be doing more, at least a couple of times a week, which is good. Okay, let's get on to DAMA and what it is. It is the premier association for data professionals around the world. And in fact, there's more than 60 chapters worldwide which form DAMA International. So DAMA Australia is one of actually more than 60 chapters around the world. And it's a, it is a not-for-profit organisation. It has been built around the idea of promoting best practices in data management and in the use of data and information. And that covers the whole gamut of data, from analytics to data security, data sharing, data quality, and all those things that we tend to talk about when we talk about data and the risks and the challenges with it. It has branches in Australia in most capital cities, including Melbourne, Sydney, Brisbane, hopefully Darwin soon, and definitely Perth and Adelaide. So it's quite an active association. It's been a bit challenging over the last 2 years with COVID. We've had to do a lot of our meetings online instead of in person, but that's also been positive in the sense that more people have had access to DAMA content and DAMA presentations. So we've actually had quite an increase in membership over the last couple of years. So people ask me, Data Management Association, what is data management? So for those of you who haven't really touched on the field of data management, I just thought I'd put the famous DAMA wheel on the screen from the Data Management Book of Knowledge. And you can think of the Data Management Book of Knowledge as a set of best practices that effectively provide you with different techniques for managing all these different aspects of data. So if you get the DMBoK, which I'll talk a little bit more about in a second, you'll find lots of recipes, lots of approaches to managing, solving, dealing with these various kinds of data-related capabilities. Data management is a profession. It's a discipline, and it requires training, awareness. There's methods, there's best practices around it. So why would you be interested as a big data person or as a data scientist in data management? Well, it turns out that a lot of the stuff that data scientists and big data people do is pretty much the stuff that's data management's been concerned with for many, many years, right? So in fact, a recent survey by Forbes found that 80% of data science time was actually in cleaning, collecting, organizing, normalizing, standardizing the data so that you could use it in the model. And if you do data management, doing that kind of thing becomes a hell of a lot easier, because one of the products of data management is the data itself, put into a form that can be used for the various purposes that the organization wants to use it in. So effectively, one of the big reasons why people are coming back to looking at data management, especially the last few years, explosion in data science, which has been fantastic and positive. but there's also now been a realization that data quality is impacting how much you can get out of that data science, especially productivity wise. So bringing data management into the equation can make a big impact on that. DAMA normally has branch meetings, and in fact, I'm pleased to say now we're out of lockdown, that will restart in 2022. That's me at the last one, in fact, doing a case study with the CFA, but that's a typical sort of, branch meeting, people there, normally do some networking, meet some people, get a presentation, could be from a case study, could be from a vendor. So it's a good environment. And if you want to attend a branch meeting, get yourself on the mailing list for DAMA Melbourne, and you'll find out when the next branch meeting's on. I mentioned the Data Management Book of Knowledge. Of course, I have a copy right here because I use it all the time, and you should probably get one. You can see it's a very big book, but of course you don't have to read it from end to end. You just read the bits that you need to when you're doing the work that you need to. So associated with the Data Management Book of Knowledge is the CDMP, which is the career path that we have in DAMA, a certification which gives individuals benefits and organisations benefits. So also, if you have a look at the DAMA website, look at CDMP. It's excellent value to join DAMA, only $100 a year, and that's even tax deductible as an individual. So, as a corporate member, $400, pretty good value, and I'd encourage you to have a look at it. Okay, so that's the plug. So we'll move on to the top.
Can I ask a question, George? One question before you dive into the data quality. Yeah. You mentioned the branch meetings. Are they open only for members, or anyone can join them?
Well, we've actually had them open to anyone, Waz. So, until that policy changes, when it does change, it'll be that you're allowed to go to a certain number a year if you're not a member. But if you are a member, you can go to all of them. Normally, that'd be about 10 to 12 a year. If you're a member, you also can receive the presentation of the presenter, and it's often videoed, and you can get access to all that immediately after it anyway. So there's benefits in joining, but yes, absolutely we would welcome anyone from this group, and anyone who's interested to join us at the next DAMA branch meeting. And it's a pretty open group, so you can pretty much attend those meetings if you turn up.
Thanks, George.
You'd be welcome. All right, so data analytics architecture. I guess I might start with sort of talking a little bit about what we mean by architecture, because boy, it's a bit like data governance. We talk about architecture, and we could be talking about networks, infrastructure, platforms, business systems, collaboration. We get so many different kinds of architectures. So we're talking about platform architecture and data architecture insofar as what we used to call data warehouses, people still do. We call them data hubs now, data lakes. So all those things that we use to do analytics from, and all the different ways that we might store the data on those platforms. So this is not about any particular technology stack, vendor. This is, it's more about architecture, which is essentially independent of any, particular cloud or vendor or solution. So this is the architecture that most organizations have deployed over the last 20 or 30 years. Some of you may be familiar with it. It's a traditional data warehouse. It was designed in the 1990s. It does a pretty good job, but there's a lot of shortcomings too. But at the time when this was conceived and designed, it was certainly a massive game changer, because the idea that you would take the data out of the operational system and move it into this thing we're calling a warehouse, and then possibly, be able to sort out any data quality issues there, and even store it in such a way that makes it easy to report off. I don't know, you know, I know there's a lot of new people in the field, but I'm sure Muaz would remember the times when you would often speak to a business person who would say it would take an hour or two to run a report, you know, because it was adding up so much data. And so the answer to that, of course, with the data warehouse, a huge leap forward. Nothing too innovative, but certainly innovative in the sense that we said, okay, well, they don't want to wait 2 hours anymore. So what we're going to do is add up every conceivable combination of it and have the answer ready. And effectively, those you know, cubes nowadays dealt with columnar databases, but those cubes were effectively a pre-aggregation of all the different ways people might want to view you know, the aggregated data. And so it would give you an instantaneous answer, and that was an amazing step forward when a business saw how quickly those you know, multi-dimensional cube models would provide you data. So this was quite a big step forward. But if we're thinking about this problem today, you know, how would we do it now? And also, there was some definite positive things about this architecture in terms of the data quality it delivered. And in fact, one of the biggest complaints we get nowadays is organizations that have moved to more agile data lake-based architectures and whatever. A lot of the benefit they got from the quality of this sort of approach has gone. Of course, it's made up for by speed and agility, but nevertheless, there are some things that they still want that high quality for, and the lakes and those sorts of approaches aren't so good at it. So this is the traditional approach, right? And I just said to you, I'm going to give it a quick sort of rating on some different aspects here, but performance-wise, great, you know, did a good job. Data integration, where we're getting a lot of different data from different places and bringing it together and making it a single view or a single model, does that really well. There's sort of multiple approaches there. Some versions of a data warehouse, what we call a federated or Kimball version of the architecture, didn't do the enterprise thing so well, but it still allowed you, for example, to take customer data from 7 different systems and bring together a single view or a single list of customers without, you know, duplicates and things like that. So pretty good at integrating data. Data quality wise though, not so good. Good in some ways, but not so good in others. Because the big problem with the data warehouse was, of course, that when I didn't want that record to be rejected, it gets rejected, and I find myself having to go back to the source system to get the original list of data because the one in the warehouse is incomplete. Because someone decided that if, for example, an address didn't have a postcode, it wasn't valid, so we're not going to load it, right? Now, this has gone on for years, and this is one of the reasons why we have that informal backdoor approach, going back to the source system, go get the original data, because I don't care if the postcode's there or not. It doesn't affect what I'm going to use the data for. And so that one-size-fits-all approach for data, not so good, but the fact that you had this high-quality data, that is good. So I've probably been a bit rough on the data warehouse. It's probably a C, really, because if you look at some of the less governed and conformed approaches like data lakes, you know, without any sort of high governance on them, they're much, much worse than this. But effectively, you know, there's some good and bad there. Let's look at how individuals and teams actually use the data in these warehouses, what they want to do with them, right? And see, let's sort of think about how well it does that. Well, you know, being able to explore and discover data, you have to know what data's in the warehouse. It doesn't usually include, you know, a catalog or something that tells you what the data is. You might be able to see what the reports that are written off the warehouse are, because maybe someone set up a portal for you to look at the reports, but discovering the different kinds of data, sometimes a bit difficult. Also, very often people want to be able to take the warehouse data and mix it up with stuff from outside the organization. You know, maybe it's come from the ABS, or maybe it's come from DELP, some, you know, some spatial data from DELP or something, you know, from data.vic. So, you know, it's not so good at letting you mix and mash up data, you know, especially when, you know, often IT departments will stick the BI tool and the like Power BI and the warehouse together as one thing. And then sometimes people say, but I want to use this BI tool on this other data set. And it starts to become problematic for them to do that because, you know, it's sort of assumed that you're going to use it just on this governed data store, the data warehouse. It's okay for data science, but there's some stuff that's not so good. Like, for example, sometimes if we're doing data science, we don't really care about conformed data that's been massaged and data quality and whatever. We just want the raw data, you know, to analyze and to, you know, put through our models. So it can, you know, it can support it, but, you know, it's not on its own going to be good enough, really. You need to be able to work with raw data straight from sources. Self-service BI, you know, so a user in the business can go and, you know, access the data. It's reasonably good at that, especially when you've got those cubes and multi-dimensional models. So, you know, with that, it's pretty good. But again, you want to also support that with an explanation of what the data means so that when the user tries to use it, you know, they understand the meaning of you know, the average field, for example, you know, average cost. What does it mean? How is it calculated? You know, and so effectively, the other thing is that, you know, when we start working with some of these other different kinds of data as well, geospatial data, even unstructured data, digital data, it's not so good with those sorts of data types. It's more good with structured data. So whatever we end up doing, I guess the point is that we want to think about these things. We want to make it easy for data scientists. We want to make it easy and support self-service BI. We want to work with different data types. We want to make it easy for people to discover not only the reports that have been written off the data, but what data is available to them as well to be able to create something themselves. The other thing is, if you think about the way that organization uses, data analysts sort of work, what happens is they usually start with, you know, an analysis that they might do themselves on a spreadsheet or something. And, you know, they might collaborate with a team member. So they work as an individual at the start, and then they might start collaborating with the team, and you know, they might be working on an analysis of, you know, some hunch they might have about a group of people who might be buying their product or something, and they want to come up with something that might highlight that. So they work together, and as they go through these steps, they start by themselves. They start working and collaborating with others, and then they get to the point that their boss sees it and goes, "Wow, this looks great. This is meaningful. This is important. Let's all share it at the next team meeting. Let's all talk about it," right? So at this point, it's being published within the business unit, right? And then, you know, someone happens to be at that meeting and says, "We would love that report too." And here's where we start to have a little bit of a governance issue, because how I went about creating that report, the sources of data I used, the way I decided to define, for example, how many hours a full-time employee would work per week in order for me to count them as a full-time employee. So I decided to use 37.5 hours, and Muaz decided to use 38 hours in his report. So all of a sudden, I've created a new version of the answer to how many people work in this place, in this organization, right? And if I start handing that out to everyone, we've got a problem. Even though you've come up with something innovative here, clearly everyone wants to see it. Giving it to the CEO could cause us problems because it may not be adopting the standards, the definitions. Also, you know, as things change over time, if everyone's going to rely on this, is there enough governance in there for us to be able to explain where the numbers came from, what they looked like in the past at a certain point in time, Is the calculation repeatable? Can we audit it back to the source system? So all those things that help us build trust about that information, are they in place? So whatever we do in an architecture going forward, we want to make sure that we consider the fact that data, usually the way people use it, goes through multiple governance steps. Now, in that data warehouse architecture we were just talking about, one of the problems is it just sort of recognizes this last one. And it just, all the rest of these are happening in the background, and even some of them are considered bad. So, you know, oh, don't use Excel and give that to that and that and that. But clearly people are going to use Excel, and clearly people are going to be doing this stuff. And clearly it's not the job of the people in the analytics area to tell the business what it is that they should be doing with, you know, their data and the analytics. So we've got to make sure we design, you know, a way to think about data quality that's going to also consider how people use data across these different, you know, steps in governance, if you like. So the big issue, of course, then with the data warehouse design that I was just showing you, one of the big issues anyway, speaking to the data quality thing, is that we take some raw data from a source system and we start to do some data quality things to it. So in data management, we talk about reference data, we talk about master data, we talk about the enterprise standard, right? And what happens is that, let me give you an example. I've got two systems. One is indicating gender with an M and an F. The other one is using 0 and 1, and we need to bring that data together. So we need to adopt a standard. So we decide to adopt the ABS standard, which is, you know, got a few different values. So we take that data and we provide some transformations and we turn it into a standard view. We standardize the reference data. Another thing we want to do is, because I've been created in the sales system and I've also been created in the employee system, but those two systems have different IDs for me, I need to be able to match and see that that's George in both systems. And that's where the master data thing comes in. It does that match, even if the systems aren't linked. And it's able to also figure out which system to trust when the two systems might differ in some features of me, such as the spelling of my name or whatever it is that, you know, the two might argue about. So that's in there too. And then we often adopt a standard in the schema, the dictionary. So for example, one system's got address line 1 and address line 2, and another system's got unit number, street name, street type as its address. So we need to take both those and turn them into the address standard that we want to use, right? And this is going on in a standard data warehouse all the time. But the issue is, again, that we don't always need it to go on, because sometimes the raw data is good enough. So again, this one-size-fits-all approach, you know, is part of the issue. And it's also one of the reasons why one of the biggest complaints we see with this data warehouse approach is, I just went to IT and asked them to add some data to the warehouse and they say it's going to take it 2 months. Well, that's why, because it's got to go through all these things. And they've got to figure out whether, you know, the data can support all of that and so on and so forth. But that's not so bad if what you're willing to pay for is the highest quality data. But when you don't need the highest quality data, you know, then it's a bit of a waste. I just put this one in here because I know some people might not know or be familiar with master data. So I just thought I'd give you a quick definition of it. It's the data that effectively provides the context for the transactions or the events that we're interested in the organization. So, you know, in this case, we've got a volunteer, a time, a date, a vehicle, a location, a property, and all together they collide in an event, which is, for example, in this case, it actually came from the CFA. So that would have been a fire, an incident. The volunteer is the volunteer responding to it, the address, the property there, the vehicle they responded with. So notice how all these things intersect at the event. And if me and someone else were using a different version of these lists in any way, it's going to cause us a problem when we try and bring the data together, right? Because someone in my list of volunteers is different from someone in yours. The spelling of me in mine is different from yours. I'm using a different property addressing system, and so on and so forth. So this is why we talk about master data management, and this is why making sure that everyone's using the same master data is important. And of course, master data has another thing that makes it important. These devices we all have data in this, collect data in their sensors, but no one could ever understand, I guess the string of bits and bytes that make up a fingerprint ID. But what they would understand is that fingerprint ID is that person. And so having this MDM capability also allows you to work with this non-human understandable data and turn it into human understandable context, right? So that's another reason why we do it, right? So, so with all of that in mind, and thinking again about what would we do if we were designing our data analytics platform, we want it not to have that one-size-fits-all data governance thing, right? We don't want just one quality of data. We should be able to do it progressively. We want to be able to support that master data management and correct data back at the source. We don't want the same bad data quality appearing again and again and again because it's never corrected. We need to be able to travel, we call it time travel, be able to travel back and forward, but not always, but with some data, we want to be able to say, what did this report look like at that particular point in time? And we certainly want to be able to tell where the number on that report came from, or where that total came from, to be able to trace it all the way back to the source data. To do that, we need to be able to, I should add, we also need to be able to support some metadata management capabilities, because if I'm using the data from that self-service point of view, Business Glossary is going to let me understand what we meant about full-time employee, Muaz. It'll say a full-time employee is someone who works at 37 and a half hours a week, and I can go and look that up. So when I see it in my report, I know what it means. I want a data dictionary to tell me that when I'm using the raw data, that field means that particular thing. That amount is a sales amount, whatever it is. And I also need some operational metadata, because I want to know how old the data I'm using is, or even how old the report I'm looking at is. So that's, when was this data last updated? Was it updated a year ago, 2 years ago, or yesterday? I need to know that, right? So I need to have some capability in this analytics platform to deal with metadata too. We also want to be able to change things pretty quickly, because one of the big shortcomings of that data warehouse architecture I showed you right at the beginning was that when we come up with the data models, which we do in DAMA, we come up with a enterprise data model that lets you integrate the data, those data standards. We want to implement that, or at least show it to people, make the data, appear in that way, in that standard format that we've all agreed is the standard. But in the way that we used to implement the traditional data warehouse, that would be a table in the database. And of course, if you've worked with databases before, and especially if you've worked with ETL before, ETL technology, which is extract, transform, and load tools that let you connect to a source system and pump data into a target, it could be a table. Well, if I change that enterprise standard, then I need to change the ETL, I need to change the table, and then I might even need to change the indexes and the relationships between that table and all the other tables. And pretty quickly, the whole thing just cascades into a small change could become a small request by the user for a change could become a big change, that needs to, recalculate the database. So whatever we do, especially nowadays with data lakes and in-memory databases, surely we can do better with that problem. So, so these are all things we're thinking about when we design our platform. And the other thing is, of course, we're going to recognize the fact that people need to be able to work with external data, other data sources that aren't in the warehouse. We want to help them be able to find those things. And, you know, they should be able to mash up the governed and the ungoverned data, the trusted and the untrusted data. And they should be able to bring that together if they want and do some sort of novel, innovative analysis. We need a better way to think about data quality and work with the business that created the data or at the source of the data to sort out any data quality problems as they arise. And we need to be able to work with both innovation using the data that's trusted with the data that's not to come up with some new way of looking at the world. But also when we're a bank and we need to provide the regulator a list of all our clients who might be under mortgage stress, we need to be able to trust that number, because if we get, if the regulator doesn't have confidence in us, of course, that could affect our ability to continue, being a bank. So there's two different requirements here, and we must be able to support both of them. We must be able to help data scientists be innovative quickly, but at the same time, when we need to provide data that leaves our organisation and goes to the government or some other body, we need to be able to provide that high quality. Right, so what's the answer? Well, the way that we go about it, typically thinking about all of that, is there's usually 3 different zones. Now, you may have seen, data lake architectures where they talk about curated and gold. This is not that, okay? I'll just be clear about that. This is more about working with individuals, working in teams, and then providing data from the enterprise point of view that you can trust, right? So we must recognize people need workspaces to work. In this area, we have low governance because, we're not going to get in their way of doing some innovation, but we are going to put some hooks in on it, because what we're going to say is there's a quota on your disk space or your data lake space. We've got a sliding window of 90 days, and we're just going to blow away anything that's not more than 90 days old. And effectively, what we're doing there is just, making sure that, if they want to keep it, they've got to publish it. If they don't want to keep it, they get rid of it. And effectively, if they publish it, we've got this business managed area where, as the analytics people or the IT department or whatever, our job is to just give them the platforms to publish it. It's up to them to keep it up to date. It's up to them to effectively, publish it. But as long as they don't start providing that more broadly to everyone in the organisation, where they might create a new source of truth. And if they do that, we want to move that into here. And in here, we've got the enterprise managed area, and notice all the data governance solutions start to appear, because when you come into this place, you have to tell us what sort of data this is. So you need to tell us about the metadata, and we need to understand if it's needed, where this data relates to the context of the enterprise, and that's where the master data management comes in. And also, if it's coming in here, we need to be able to measure its data quality, right? So, so that's another aspect of it. But notice that, in fact, it's not just one store here. There's actually 3 sort of areas: this one, and this one. And this one here is about effectively fast ingestion. This one is about applying the enterprise standards. And this one's about bringing that data together into the various different ways that people might want to see it to support a dashboard, an analytical view, or whatever it is. And you don't have to go through every single one of those steps every time. So this is a bit of a, that was a governance view that you just saw. So if we were sort of drawing it more as a sort of architectural data architecture view, you've got your, often that raw storage area at the front is a data lake. We then, we come in, we ingest. Now notice the metadata gate. which stops you bringing in anything you like anytime and stopping this from becoming a data swamp. If you don't have the metagate, you end up with the old shared network drive data lake, right? Where it's just piling up with lots and lots of stuff. So the rule is, if you're going to put it here, we need to know what it is, because we might already have one. We might already have a more trusted one. Optionally, after I go to step one, this is now available to everyone. They can report off of it. Data scientists can use it. In the old warehouse architecture, this was the staging area, and you couldn't access the data here unless you sort of knew someone, right? So, you know, it wasn't available for publish, but in this architecture, it is. It doesn't have to be, but it is if you want it to be. We go up from here optionally into conforming the data. That's where we're doing the reference data standards and all that, and standardizing it. And then once we've done that, once we have a common customer code, once we have a common address code, it becomes easy to integrate the data, and especially to use some of those new technologies like columnar databases, because the data's already matched. So adding it up at the last second using an in-memory columnar database becomes perfect, easy, right? You can do it. You can do a dimensional model, a cube on the spot, because the data's been matched in this previous step. The conform store requires you to do some enterprise data modeling, and I've just used a little example from you know, one of our clients here to show you the sorts of things that might be in that data model. That data model can take on the different kinds of forms, but we like to use something called Data Vault for that nowadays. That's something that we use a lot of, but not everyone does. Some people use third normal form or normalized or all sorts of things. But, you know, this is a enterprise standard, and the idea is to conform the data and then make it available if people want to use it. Of course, then you've got your reports and things that hang off all of that. So I talked about data quality, and I want to talk to you about data quality specifically from an analytics point of view. You know, often we produce a report and people say, you know, that data is crap. I don't believe the report. And, you know, we start to think that it's up to us to, you know, we have some responsibility over the data quality, or it's our job to make sure that the quality of the data coming in is, you know, is reasonable before we make it available and so on. This idea that the data is good or bad is not a very good idea, not a very sophisticated idea, because depending on what I want to use the data for, it could be good or it could be bad. If I've got a 1 week old exchange rate and I'm trying to figure out whether to open an office in San Francisco, it might be good enough to work out a rough number for that. But if my boss rings me and says, should I exchange this $1 million now to US dollars? I'm probably thinking to myself, I need a spot rate. The 1 week old rate is not good enough for that. So what we need to do is move away from thinking about data quality being good or bad, because that's got some context to it. It depends on what we're using it for, to making sure that the data quality is as we expect it to be. So what that's about is making sure that it's in the form that we expect it to be. No one changed the schema on us. They didn't move from 7 columns to 9. The data's only a day old because that's what it was supposed to be, not a week old. It came through the trusted source it was supposed to. And so when I check those things, when I ingest it, I can tell people it's exactly as we expected it to be. And now it's up to you to determine whether it's useful for you, right? For your purpose. And extending that idea even further, there's actually 4 separate kinds of data quality that often get mixed up in one conversation. But if you think about this, you'll start to understand a little bit more separation here, and where your responsibility might come in as a data specialist who's doing analytics or doing data science. At the point that they're entering data, we need to have some way of measuring how good the data that they're entering is. Because we need to tell them when they're entering bad data, it's happened at the time that you entered it. So some things to do with data quality should be focused on measuring the quality in the application where it was created, right? System of entry, as we call it. Another type of data quality checking is going to be measuring whether the data quality is good enough for a specific purpose. So that's the thing that I just talked to you about, the exchange rate, the 1 week old versus a day old, right? So, but that's dependent on the context that the business wants to use it for. So that's another kind of data quality measurement. Then, if I've got a data hub that I'm creating or a data analytics platform, I need to be able to tell people how, like whether the data that they're consuming coming off it is up to date, consistent with the format that we've described in the dictionary, and so on and so forth. So that's about making sure that it's consistent and as expected to be, just as I described with the Big Mac a second ago, right? And I should have said with the Big Mac, by the way, the reason why the Big Mac was there was because no matter where you go in the world, if you buy a Big Mac, you know what quality you're getting. Is it good or bad? Some people say it's really good. If they're hungry, some people say it's bad. And so I should have told you that story at the previous slide, but that's why that was there, because it's about, letting people know, it's as we expect it to be, and then let them buy it or not, okay? Use it or not. Finally, we need to be able to tell them, if needed, how close to the enterprise standard is this piece of data? How well does it match the enterprise standards? So there's actually 4 different kinds of data quality we actually need to be concerned about. And notice that we normally have this as one kind in our heads, and often, it's hard to even understand how all of this gets unpacked in different ways and whose responsibility is. And of course, that's where data governance starts to come in. Now, I've explained what those are. All I want to add to that really is to bring this all together, we actually need a continuous process that's going on, effectively measuring the quality of data across different dimensions, such as the ones I just showed you, providing a way for users to be able to raise issues with the data that they use, and then working with your various data governance groupings, owners, stewards, to correct, resolve, and sort out those issues. And that's your continuous process. And without any more talk of data quality, I'm happy to take some questions, and hopefully you got some sort of insight out of that.